We are looking at enhancing the number hunt project from the YByte Python curriculum available at www.ybyte.in. Now, in the vanilla plain game, we build this 1D search where first we guess the number that computer searches and then the computer guesses for us using, let's say, linear search or as an enhancement, a binary search. Now we saw how we can extend this to two-dimensional search, which is pretty interesting. Let's see how we can get the computer to guess this in also in a two-dimensional search. So, really the process can continue pretty much like it was doing in the one-dimensional game. Basically, for example, in linear search, we can make some fixed steps in X and Y directions, keep changing the step size as we overshoot the target so that we make sure that we converge. The challenge really is that how do I make this code compact and not repetitive? Because now we are dealing with movement on both X and Y directions. Now, just to understand this problem a little bit better, imagine there is guess X, guess Y, there is guess step X, guess step Y, there's previous answer X, previous answer Y. So the code can get quite repetitive, quite fast, which can make it hard to read. Of course, it's not wrong to do a repetitive code. If you're comfortable that way, go ahead and do it. But what we will see here is how I can make this code compact and still make it work. And really the trick is to use lists because that makes the code really nice. So what we will do is we'll convert all the variables that we had into lists. For example, guess will again be two elements. Guess for X and Y coordinates. So first element is for X, second for Y. Guess step will be a list again. Previous answers will be a list. And I'll create one more string called XY. I'll use this for printing. We'll see later. So let's just go to a game and make these changes. So I go in here. I say, okay, look, guess is now a list. By square brackets, I make it a list. Likewise, the guess step is, let's say, a list. Previous answer is also a list. So I add one more of this. And I just create this xy is equal to as a string as x and y, and we'll see the usage for this a little bit later. So now everything is kind of compactly represented as a list. Like I said, the idea is that we'll have this list available. We'll run the code twice, once for x, once for y, and we will do this using the for loop. So code stays compact. It's kind of easy to understand later on and quite nice to look at. So let's get started with getting the player's response. Well, player is going to ask us a question. Now, let's say, for example, are you at? Now, remember my guess here is now now a list. So I just going to say, are you at guess, for example, 0? Let's say plus. So I have to do this a little bit carefully. Plus say str, say guess 1 and plus, and I think that's it. So you just hear this. Okay, so yes thing. And now finally I just tell my user, say 2 letters please. So basically I'm expecting user to give me, for example, ss, to say okay, I'm smaller than x, smaller than y as well, ys, sy, and so on and so forth. That part is all right. Okay, is I think quite okay. So I just come in here and I say, okay, look, now my answer has got 2 elements. Again, the first one stands for, let's say, say first one stands for, say, the x, next one stands for y. So what I will do is that I'll take this entire code, whatever I had earlier, I'm going to say, okay, look, let me move this all inside a for loop. Now remember, for loop is basically a repeat loop. I'm going to repeat this twice, in range, say 2, which means kk will move with this loop. Kk will be 1 first, so kk will be 0 first and then 1. So I'm going to just, move this entire thing inside. Of course, I'll have to change this a little bit. So I'm going to see, look, if answer, if remember kk, first I run with kk equals to 0. So I just go and say if attempts more than 1 and answer kk is not equal to previous answer kk. Now notice these are all lists now. So when kk is 0, we are looking at the x-axis. I just go and say, look, guess step, say kk is guess step kk minus 1. And previous answer kk is equal to, say, answer kk. Now this is going to basically cater for both kk 0 and 1 because this is in a for loop. But first x will get done, next y will get done. I go and see here, okay, if look, answer kk is, let's say, lower is equal to s, then my guess kk will be equal to guess kk minus guess step kk, because remember both are aligned. If answer kk is kk, say, dot lower is equal to l, well, again I'm going to increase my guess here by saying, let's say, sorry, I have to be careful. Guess kk is equal to guess kk plus say guess step kk. And finally, if my answer to that particular, now this is a little bit different from the earlier case. So I'm saying, okay, if my answer for that particular kk, which is could be 0 or 1, is equal to y, that does not mean I've converged. It only means that I have, um, so I'm just going to print over here. Okay, so let's say here I say print. For example, I say, locked on. Now, what am I logged on? If kk is 0, I'm logged on x, which means I've finalized the x. If kk is 1, I've logged on, y. So I'm just going to say x, y, kk, because remember xy is the string that I said we'll use for printing, and this is where the usage is. Um, I'm still not done with this because we have just looked at one coordinate. I just want to make sure that my these guesses do not exceed the limit. So I say if say guess, kk is say greater than 100, then I just said say guess kk uh, say equals to 100. And if let's say no guess kk is say less than 0 for whatever reason, actually we can make it less than 1 because that's the lower limit, but let's just make it 0. That's okay. So I say guess kk is this one, then I say guess say kk is say equal to 0. So this makes sure that the guess never goes beyond the boundaries. But now comes a very important thing that, once I'm out of this for loop, remember now this is a for loop. So this entire thing is going to run for kk equals 0, 1 first, and then kk equals to 1. So I'll know individually if I've logged on k and I mean logged on x and y, but I must now check for my answer for both x and y. So I go and say, okay, look, if answer, say 0 dot lower, uh, so which means convert to lowercase, is equal to say y, and answer, say 1 dot lower is equal to say y. Now this is very similar to our missing operators project when we looked at both the answers. If this happens, then well, definitely I'm done. So I'm going to have to, indent this line. I took whatever number of attempts to solve it, and done becomes true. Now this is important to understand that this if condition is outside the for loop, and in fact I have to unindent it as a result. So we'll see this in just a moment. Let's say if I close, if I sort of let's say, yeah, so I've got all these if conditions, and this helps me to see, for example, my for loop with respect to my if condition here. This if has to be outside the for loop because this happens for both kk 0 and 1, and then finally look at the right answer. Okay, so I should unindent these two as well, otherwise that's a problem. Great, so now it's fine, and really this is all I need. Let's see if this works, and if everything is in place here. So I'm just going to directly come to this, like I said. So I'm hiding somewhere, hide, let's say it says hide somewhere, and I'll find you. Let's say I go and hide at 65 25, so 65 on x, 25 on y. I'll start with, let's say, I click enter, it asks me, are you at 0 0? I say, well, larger and larger. So it tries 10 10. I say larger and larger. Remember, I'm at 65 25. I say larger and larger. Now I have to say larger on x but smaller on y. And notice what it does. It goes larger on x 40 and then 21 because really that's how the code has been done. So 40 21. Well, I need to go larger on both. So it's 50 29. I need to go larger smaller. 60 22, larger. It's 70 28. I need to go smaller. Now this is really interesting actually if you think about it. 61 23, I need to go larger. Uh, so I need to go 69 27, I need to go smaller, but you can clearly see that I'm converging now. I'm going to say larger, and say smaller. It goes to 63 25. I've locked onto y, so I'm going to say, well, larger and ly. It says, okay, I'm logged on y, so that's good. I'm at, are you at 67 25? Well, I need to go smaller than that, but I'm logged on y. I say, so says 64 25. Well, I need to go larger and y, and it says 66 25. I say smaller and y. I'm at 65 25. Yes, and I am done. It took me 17 attempts to get here, but I did get here. And the best part is the way this code is written is kind of clean, right? It's not, just imagine if I did not use this for loop, it would be like, if answer 0 is, let's say, lower dot s, then guess X is something, guess Y is something else, and the code will become quite messy. But this now is a lot more compact and in fact, quite neatly done. I hope you found this interesting and useful. In general, if you think this way of learning works for you, it makes you think, it makes you enjoy programming, look at our website because we have lots of such activities. Take care. Thank you so much. Bye bye.